Good morning from Mission Control Houston. We are live inside the Artemis Flight Control Room here at the Johnson Space Center. We are coming to you live with 24/7 continuous coverage of the Artemis 2 mission. We are at a mission elapsed time of 4 days, 14 hours, 26 minutes, and counting. The Orbit 3 team of flight controllers is currently on shift planning the much anticipated day ahead. Speaking of the day ahead, we are about 4 hours, 57 minutes and counting to pass the Apollo 13 distance record. That distance record marks the furthest humans have ever traveled into deep space. In addition to that, we are counting down 10 hours, 1 minute and counting from our lunar flyby, which you will catch when Flight Day 6 kicks off right here with my colleagues Leah Cheshire Mustachio and Anna Schneider. Orion is currently 243,000 miles away from Earth and just 22,000 miles away from the moon. You see that bright moon in the distance on the vehicle. On the vehicle. For now, let's take a look back at Flight Day 5. Here are your mission highlights. For now, this is Mission Control Houston.
Hello, Reed, Victor, Christina, and Jeremy. This is Apollo 16 astronaut Charlie Duke. John Young and I landed on the moon in 1972 in a lunar module we named Orion. I'm glad to see a different kind of Orion helping return humans to the moon as America charts the course to the lunar surface. Below you on the moon is a photo of my family. I pray it reminds you that we in America and all of the world are cheering you on. Thanks to you and the whole team on the ground for building on our Apollo legacy with Artemis. Godspeed and safe travels home.
All right, Reed, we will put in work right now, so we're going to hop on PCD-1. It was great working with all of y'all. I'm handing over here to Jams shortly, and this is my last shift here with y'all, so it's been a great pleasure. Y'all are doing awesome, and can't wait to see y'all back stateside.
Thanks, Mike. Absolutely excellent. If you want to do one final contact, we can switch over to any OE that you want. We can do as many as you want. And then one parting word, if you could please contact Frank Rubio and have him tell my kids to start emailing the other crew members here so that I can at least talk to them. That would be a huge help. Thank you.
Hey, Reed, that's a simple thing. I'll make sure it gets done. Have a good one.
Mike, integrity, check.
Christine, I got you loud and clear. How about me?
Yeah, buddy, we have you the same. It's been great working with you. Thank you for all the help and support.
For sure. Y'all have been amazing. I've loved every minute of it.
Good morning, good afternoon, happy Easter to all of you who celebrate, and welcome to the Artemis Mission Control Room here at Johnson Space Center in Houston, Texas. We are starting Flight Day 5. The astronauts just woke up at 11:05 a.m. Central Time. Currently, the teams are handing over from Orbit 1 from the Orbit 3 team to the Orbit 1 team led by Jeff Radigan here in Mission Control. It's going to be a busy day for the crew with their Ox suit demo in which they will be donning their spacesuits rapidly as if they were in an emergency. Currently, Orion is over 63,000 ET mission elapsed time, 3 days, 18 hours, and 28 minutes.
Integrity crew, we are rolling Orion by 20 degrees to improve optical comm.
Those communications you just heard called to the crew were from Capcom Jenny Gibbons. She is a Canadian Space Agency astronaut and backup Artemis II astronaut. She'll be the voice you hear speaking with the crew from the ground today. That information was about the optical communications system, letting the crew know that they are going to maneuver the spacecraft to get better pointing for that optical communications. This OPCOM system allows the team to transmit science data, procedures, flight plans, communications, and more as a link between Orion and Mission Control. These are laser communications, so they use infrared light rather than traditional radio waves, and that allows more data to be sent.
You are welcome to come on board.
Copy, Christina. We are on board with you. Thank you.
You're looking at a live view inside the Orion spacecraft, now just 61,919 miles away from the moon, the destination of this flight and where they will arrive for the flyby tomorrow. As we get a live look inside the cabin closest to the camera, NASA astronaut Christina Cook, and behind her, Canadian Space Agency astronaut Jeremy Hansen, his first flight to space. We are entering flight day 5. The crew is still in their post-sleep period and configuring the spacecraft for the day's events. Immediately upon wake up and before the astronauts brush their teeth or exercise, they are asked to take a saliva collection. Saliva provides a unique window into human immune system functions in a deep space environment. So dry saliva is collected before, during, and after the mission. The crew blots it onto special paper in pocket-sized booklets.
Go ahead.
Yeah, low priority. Can you please tell me a good stow location for the 2 lens caps? I looked up lens cap in the packing plan and wasn't able to find anything. Thanks for the help. Low priority.
Copy, Christina. IVA is looking at it.
As we've seen throughout the mission, the crew will call down when they need to find something or when they need to store something. Everything aboard the spacecraft is tracked so it can be easily accessible or easily stowed and found later.
Houston, Integrity, good morning and happy Easter to everyone down on Earth. We wanted to kick off our Easter Sunday by honoring our crewmate, Jeremy Hansen. We have a long-standing tradition in the astronaut office of the traditional astronaut pin, and when you fly in space, you change from silver to gold, and so we figured today was a perfect day to honor our friend, Canadian astronaut Jeremy Hansen, with his flown astro pin. Wow, that sounds like it took a lot of people to make this little representation that we have in the office, this tradition, come to reality for me, so a lot of gratitude for all those people. It's a pretty special experience. Thanks for doing this, guys.
Congratulations.
Well deserved. It's an honor to fly with you, Jeremy, and to be here when you get your gold astronaut wings. We wanted to take a minute to commemorate the holiday that we have. This time of year is something that many religions and many cultures hold dear. It's a time of emotions such as joy, as well as solemnness, honoring what's going on both in our world and in our religious beliefs. Another aspect of that is our family traditions. And I know for me, if I was on the earth right now, I would be with my family in Houston, the Monte Rosas, and we would be hiding confetti eggs in the backyard and watching two very sweet little girls go try to find them. So to commemorate that on board, we did hide a few eggs around the cabin. They were the dehydrated scrambled egg variety, but we're all pretty happy with them.
That's wonderful. We'll keep an eye out.
First, I wanted to just say happy birthday to my father, Victor Glover Sr., and happy Easter to everyone down there on Earth. And with that, I will pass it off to Jeremy.
Thanks, Victor. Happy Easter, everyone. We're talking up here as a crew, and we did want to send a special Easter message on this day. And, no matter your faith or religion, for me, the teachings of Jesus were always a very simple truth of love, universal love. Love yourself and love others. And something for us being up here and looking back at all of you through one tiny window is that just resonates 100% true. And our goal as humanity should be to just follow in that example. There were many examples in the past, but that's one example of love that we can just all follow in those footsteps, and it'll serve us well.
And with that, Houston, we are eager and ready to start our exciting day of suit ops with you all. And we don't have any specific comments yet, but ready to hear what you've got for us.
Thank you, Integrity. A lot of gratitude for that message down here, and it's wonderful to see Jeremy get that pin. So thank you for sharing with us.
Inside the cabin, the crew is preparing the spacecraft for the OX suit demo. Orion Crew Survival System Suit. That's what OX stands for. Today they will be donning their suits or getting into those suits. 2 will be doing so rapidly and 2 will be doing so at a normal pace. These suits are what the crew members wear during launch and re-entry. It's also what would protect them in the event of a depressurization in the spacecraft. These Orion Crew Survival System suits could keep the crew member wearing it in a breathable atmosphere for up to 6 days if Orion were to depressurize. Now, this is obviously the first time that humans have ever flown aboard Orion, so the first time we've gotten the opportunity to test out these suits. So after they put on the suits, they will pressurize them, and then they will install their seats. They uninstalled their seats following arrival in their high Earth orbit. And with these suits being pressurized, that seat install would be a little more difficult.
Jenny, we are ready for the position to latch the leg assemblies onto the seat backs for 1 and 2.
For both seats 1 and 2, you're looking for the seat pan position. You will be putting the pit pins in position 3 and 7 for both seats.
James, we are nearing the time of having y'all go off board so that we can get into our suits. Just wanted to check in with you on timing or anything else you've noted that you want to share before we get into that.
Thanks for letting us know, Christina. That syncs with everything that we've been tracking. We just want to update you that we don't believe that we will do any objectives at the lower pressure, so at 3.7 PSID as your suit delta pressure, and we're also looking at adjusting the objectives during the first set as well. So we'll continue to talk about that, and in the meantime, you're go to continue.
Houston Integrity, seats 1 and 2, rapids on, complete.
Copy. Rapid dawn complete, seats 1 and 2. Thank you.
As part of this test, we have vented some of the cabin pressure overboard. It is now 11.0 psi inside the cabin. Again, today we are conducting a demonstration of these crew survival system suits. Now that the suits are pressurized, it can be more difficult for the astronauts to maneuver about the cabin. They are obviously also connected to umbilicals, which make another hurdle into moving around the spacecraft. The crew will soon be moving into their midday meal period. And then later this afternoon, having the OTC-3 burn, that's Outbound Trajectory Correction 3. We did cancel OTCs 1 and 2. These small outbound trajectory correction burns help keep us on the proper trajectory for our lunar flyby and our return to Earth.
Integrity, we have you the same. Please execute procedure 2.1.0, cabin leak suspected. We need to get the cabin pressure control to maintenance. This will perform a cabin O2 introduction.
Again, we are working on getting the crew audio back into the broadcast, but you heard Capcom Jenny Gibbons, CSA astronaut in Artemis 2 backup, communicating with the crew some of our recent changes on the spacecraft. As we went into the LOS with the crew, that loss of signal, which we were expecting, we also noticed a cabin fan change, which caused a cabin leak suspect warning. There was no cabin leak. We needed to mode back to a maintenance option and reintroduce oxygen into the cabin.
All right, Jenny. The moon is decidedly large out the window today. We can see all of Apollo, all of Oriental, annular ring. We can see, I'm 99% sure, Ohm, see Pirazo very easily, and just getting over. Can't quite pick up Vavilov yet, but that far side that is right on the limb is extremely mountainous. Try to get some pictures, but it's a high grazing angle. Still primarily seeing whites, grays. Very light, very, very faint, but it's a great view. It's beautiful. And on the near side, Aristarchus is by far the most prominent feature. It is really just glowing bright right now.
That's beautiful, Reed. Thanks for bringing us all up there with you.
And for the science team, Pirazo and Aristarchus have the same albedo level right now. They're the same level of brightness. And then looking down, Copernicus is just a little bit dimmer, but it's close.
Houston Integrity, just one other observation. Looking at the Terminator, it's almost a full moon from this perspective, but we got the Terminator on the western edge of the moon, about 1 Oriental diameter from Oriental, and just with our plain eyes, you can really start to see topography. There is elevation on the moon, not just variation in color. And that already makes the moon look wildly different.
Houston Integrity confirming your go-no-go for this burn.
Integrity Houston, MCC has pulled go for the burn.
Integrity copies.
This is Artemis Mission Control in Houston, Texas. We just heard confirmation there that the team here in Mission Control has pulled go for the upcoming outbound trajectory correction burn 3. This burn expected to take place in about 26 minutes from now, and it will be an approximately 19-second burn using the auxiliary engines on the Orion spacecraft. There were previously 2 other outbound trajectory correction burns on flight days 3 and 4 that ended up being canceled as it was determined they were no longer needed due to the accuracy of the translunar injection burn on flight day 2. However, the team decided to go ahead and execute this outbound trajectory correction burn 3 today on flight day 5 to ensure an accurate trajectory as the spacecraft begins to make its way around the moon and back to Earth to minimize further larger trajectory corrections that may be needed on the return journey.
Integrity Houston, maneuver to burn attitude starting in about 3 minutes. Integrity Houston, we're in burn attitude.
We see the same.
This is Artemis Mission Control in Houston, Texas. We just heard that confirmation called up to the crew on board the Orion spacecraft that the spacecraft has maneuvered to the correct burn attitude in preparation for the upcoming outbound trajectory correction 3 burn scheduled to take place in about 5 minutes from now. This is Artemis Mission Control in Houston, Texas. You're now seeing a live view of the Orion spacecraft, the exterior of the spacecraft, as we are about 2 minutes out from the upcoming outbound trajectory correction 3 burn. That burn is expected to last about 19 seconds, taking place around 10:03 p.m. Central, 11:03 p.m. Eastern Time. This burn will fine-tune the trajectory of the Orion spacecraft to ensure it stays on target for its journey around the moon and back. This is Artemis Mission Control. We are about 30 seconds away from the time of ignition for the outbound trajectory correction burn. That is when the auxiliary thrusters on the Orion spacecraft service module will begin firing to complete the outbound trajectory correction burn and fine-tune its trajectory. And we have confirmation that that outbound trajectory correction burn is now underway. And we now have confirmation that that burn has completed. Again, that was an approximately 19-second burn using the auxiliary thrusters on the Orion spacecraft service module. That burn completed at 10:03 p.m. Central Time, 11:03 p.m. Eastern Time to further fine-tune the Orion spacecraft's trajectory as it continues to make its way around the moon, and it was a good burn.
Integrity Houston, good burn. We are assessing the details.
Good news, and we see the same. Thanks, Mark. Great to finally do a burn.
I know. It's a nice, beautiful little burn, too. Hey, be advised we are maneuvering for opportunistic science, and you would need to configure your D5 and Z9 cameras for that, like yesterday.
We are tracking and looking forward to it very much. We had a gorgeous view of a very big moon right out of window 2 during that burn. Well, right before the burn, before we maneuvered. It was awesome.
And looks like we'll be back at window 2 for this as well.
This is Artemis Mission Control. About 7 minutes ago, the Orion spacecraft executed the outbound trajectory correction 3 burn to fine-tune the trajectory of the Orion spacecraft as it continues to make its way around the moon, with that lunar flyby planned for tomorrow on flight day 6. Now that that outbound trajectory correction burn is complete, teams will be maneuvering the Orion spacecraft into an attitude to be able to capture some opportunistic imaging of the moon.
Good morning from Mission Control Houston. We are in the Artemis Flight Control Room here at the Johnson Space Center, coming to you live with our 24/7 continuous coverage of the Artemis 2 mission. I'm Nilofer Ramji with NASA Communications, and the team of Orbit 3 flight controllers are currently in the room planning the day ahead as the crew prepares to wake up in the next hour and 18 minutes counting down. We are at a mission elapsed time of 4 days, 14 hours, and 56 minutes and counting. The Orion spacecraft, called Integrity, is 243 miles away from Earth and just 21,000 miles away from the Moon, which is our big plan for today. The crew aboard Orion, as well as those currently in mission control, as well as the multiple backrooms supporting the mission, are incredibly excited for the various milestones that the crew will be experiencing today. That first milestone begins with the Apollo distance record. The Apollo distance record signifies the furthest humans have ever traveled away from Earth. That distance record is coming up in about 4 hours, 26 minutes and counting. In addition to that, we will also conduct a lunar flyby, and that lunar flyby period is going to be happening in about 9.5 hours and counting. The lunar observations for this mission are from a higher vantage point that are a little bit farther than Apollo's lunar orbits. On average, astronauts can observe both poles and large-scale geologic features in a single view. So depending on the illumination conditions, Artemis 2 astronauts will become the first humans to directly observe a certain far side of the moon regions with unaided eyes. The human eyes are trained and remain one of the most powerful scientific tools NASA can send to space. During Artemis 2, astronauts have been able to quickly survey wide areas and adjust their focus in real time, describe relationships between features, capabilities that cameras and instruments alone cannot replicate. The crew observed the same regions that we're going to see a little bit later today multiple times under changing lighting conditions during a single flyby, so they're getting perspectives that would take robotic missions years to accumulate. The audio descriptions that you'll hear later today, the situational reports, are what we call sit reps, and crew annotations will provide essential context that enhances the scientific value of imagery. There are about 30 targets included. They're tied to past robotic missions, current science priorities, and future exploration sites, including regions near the lunar South Pole considered for future Artemis missions, and observing how surface features such as lighting evolves that allows scientists to better understand color, albedo, texture, morphology, and other key information for interpreting orbital and surface data. Currently, you are seeing live views from one of Orion's solar arrays. We see the moon right there in the distance. The solar arrays are currently focused on the vehicle, and that is looking up at the service module of the Orion spacecraft. And as we get closer and closer to the moon, those solar arrays will move out just slightly to focus more on the moon. We'll continue to provide you with live 24/7 coverage of the Artemis 2 mission. For now, this is Mission Control Houston. Welcome back to the Artemis Flight Control Room here at the Johnson Space Center. We are continuing to come to you live with our 24/7 mission coverage of the Artemis 2 mission. The crew is waking up in just under an hour from now, and we are going to be beginning flight day 6. This is the lunar flyby day. I'm clearly incredibly excited for that day, and I know that we had Trevor here yesterday with us. He's back, our science officer on console here. Trevor, tell us about the lunar targeting plan for today.
Yeah, I didn't think it could get any exciting, but we are super stoked right now to get into the lunar flyby, and that's all going to be driven by this lunar targeting plan, or LTP, I might refer to it as. And so Kelsey showed this at the briefing yesterday, if folks were watching, but we have a good screenshot here. And so this is what the crew is going to be using to step through those observational targets that we have for them. So you see those listed in the upper left. There's some examples there. There's a total of 30 of those operational targets that they'll be stepping through as they go around the moon. And then some of those targets will also be during the eclipse time. It's all spread out over 5 different shifts where the crew will be at different places inside the cabin. So some will be up at the window 2 and 3, the center windows, and then some crew will be supporting as they are making those observations. And then they switch out throughout those observational shifts between those 5 that I mentioned.
Excellent. That is very helpful to understand. I have one follow-up question to the lunar targeting plan. We have what we called LOS and AOS, and we see this a lot with the space station. We have the loss of signal and the acquisition of signal. If I remember correctly, we won't hear from the crew as they go through the far side for about 40 minutes. Is that right?
Yeah, that's approximately right. So once Earth starts to set, we get into that LOS time. And so they'll be making observations still and recording those on their personal computing devices, or PCDs. And then we'll see Earth rise, which will super exciting time when Earth's going to start peeking back out, and we expect to get signal back at that time.
And as long as our signal is cooperating and everything should be good, the world will see Earth rise with us, we hope. This is the iconic image that was taken in Apollo 8, where we see the horizon of the moon and Earth coming up. That is, I'm excited. Give me goosebumps. You talked a little bit about the eclipse as well. The astronauts will experience an eclipse from orbit. So how is that different from an eclipse that we would experience here on Earth?
It's a little bit different, just based on going to see the sun as a small disk disappear behind the moon for about that 50 minutes period, and then pop back out 50 minutes later. And so they have more of a time to enjoy the sun setting and the sun rising. But the unique part of that is, they'll be able to observe the moon during that time with the sun out of view. And so we have some unique targets that we're also looking forward to them capturing during that time.
That's fantastic. And as you're speaking, I'm realizing it is April 2026, and in April 2024 was when we in North America here experienced that total eclipse that took place, where we had to wear specific protective eyewear, and we saw that corona that you described. Will the crew have to wear anything protective as they're experiencing the eclipse? Will they have to roll up their windows? How does that work?
Yeah, we do have some protective eyewear, much like what folks wore for some of the Earth eclipse, and so they'll be using that just to make sure that we're eye safe during those times when Earth is setting and when Earth is rising. And then as soon as it peaks behind or goes behind the moon and peaks back out when it starts to rise again, they'll be making these incredible observations that we're super excited about.
I can't wait for all of these pictures to come down so we can share them with all of you watching. You talked about Earth rise, Earth set, and Earth rise. So I described a little bit about what Earth rise is. So just for everybody watching, Earth set, can you talk a little bit about that?
Yeah, that'll be actually, of all these, sunset, sunrise, or the Earth set, sorry, I was confused. The Earth set will be happening first. And so
got it.
They'll be during that 4th observational period. The Earth set will be kind of peaking, the Earth will show up in their window, come across their window, and then we'll see it go behind the moon. So I know the team, the SIR, the science evaluation room, is really excited about that time. I think it's going to hit everybody in a emotionally a little bit different way. But yeah, super excited of when that happens. And like I said, that'll be the first thing of all these Earth sunrise sets that will happen.
So I cannot wait again for the photos. You mentioned the SIR. Those of us that are sitting in this room have several back rooms that are supporting us. Tell us about the SIR.
Yeah, the Science Evaluation Room, or the SIR, is something new for Artemis missions, and so it parallels a little bit of what they did in Apollo, and it's an incredible facility, and more importantly, incredible team that is so excited for today. So they will be doing a lot of activities in support of the front room position here, and they'll be then crunching all this data in a very fast way to be able to have a great crew conference on Flight Day 7 and get some of the information that may be timely back from the crew before they land on, splashdown on Flight Day 10.
So a large team supporting you here on console, and then we have Kelsey Young coming on for Orbit 1 and Angela Garcia for Orbit 2, along with a large team that's going to be watching, cheering you on. We can't wait to see the SIR. We'll have views in the SIR just like we have here in Mission Control. Trevor, good luck today. I'm not going to congratulate you until after the fact, but just really exciting to be here on the heels of Flight Day 6. So we'll continue to provide you live coverage of that lunar flyby that's coming up. I'm just looking at my board in just under 9 hours, or just over 9 hours from now. As mentioned, we are at a mission elapsed time of 4 days, 15 hours, 24 minutes, and counting. And this is Mission Control Houston, where we will continue to provide you live 24/7 coverage. Good morning from Mission Control Houston here in the Artemis Flight Control Room at NASA's Johnson Space Center. We are coming to you live with our 24/7 continuous coverage of the Artemis 2 mission. The crew is currently in their sleep period aboard the Orion spacecraft named Integrity. At a mission elapsed time of 4 days, 16 hours, and 1 minute, we are getting closer and closer to the moon than we are to Earth. We are currently about 244,000 miles and counting from Earth and about 19,000 miles away from the moon. There are a couple of milestones that I wish to share with the group this morning. First off, we will be passing our Apollo 13 distance record. That's the furthest humans have traveled away from Earth. That is scheduled to take place today at a mission elapsed time of 5 days, 30 minutes. Integrity will reach a max distance from Earth of 252,021 statute miles. This will surpass the Apollo 13 distance record by 3,366 statute miles. Integrity's currently on a trajectory that will carry it to the closest approach to the moon of 4,070 statute miles. That's the closest the vehicle will get to the moon. In addition to that, the spacecraft will be traveling at a speed of 60,863 miles relative to Earth, but that's just a little bit different because we are actually in the lunar sphere of influence and the vehicle is being pulled by the moon's gravitational pull. So that velocity is actually reduced since Orion is in that sphere of influence. This means that Orion will be traveling only at 3,139 miles an hour relative to the moon. Once we complete the lunar flyby today, we will depart the lunar sphere of influence, which will take place tomorrow, and we will be captured by Earth's gravitational pull. Essentially, what that means is that as that pull gets stronger and stronger during our return to Earth, this will speed up the vehicle to make us swing around the moon and head back home and splash down off the coast of the Pacific. We'll continue to provide live updates for you here from Mission Control. The crew is scheduled to wake up from their sleep period in about 11 minutes and counting. For now, this is Mission Control Houston. This is Mission Control Houston here in the Artemis Flight Control Room. At a mission elapsed time of 4 days, 16 hours, and 7 minutes, I wanted to provide a quick update on the different milestones and times today that we will experience the lunar flyby. Today is Monday, April 6th, and we are in Houston, so that is in Central Daylight Time. At 12:56 p.m., Integrity will pass the Apollo 13 distance record by humans of 248,655 statute miles from Earth. At 1:45 p.m. Central Daylight Time, the lunar observation period will begin. The crew will complete some lunar observations before we enter the loss of signal period, which is scheduled for 5:44 p.m. Central Time. This is when Integrity begins its transit behind the moon. At 6:02 p.m., Integrity makes its closest approach to the moon at a distance of 4,070 miles. And at 6:07 p.m., Integrity reaches the farthest distance from Earth at a distance of 252,760 miles. That's about 4,105 miles farther than Apollo 13. At 6:25 p.m., we get the acquisition of signal, which essentially means that Integrity will emerge from behind the moon and begin its journey back to Earth. At 7:35 p.m., the solar eclipse period will begin. And at 8:20 p.m., the lunar observation period will end. Finally, at 8:32 p.m., the solar eclipse period will end. Now, all of this is happening after the crew entered the lunar sphere of influence in their pre-sleep period. Tomorrow, on Tuesday, April 7th, at 12:25 p.m. Central Daylight Time, Integrity will exit the lunar sphere of influence. This will happen when Integrity is at 41,072 miles from the moon. This is when Earth's gravitational pull will increase the velocity of the vehicle to speed up and re-enter Earth's atmosphere and splash down off the coast of the Pacific. For now, this is Mission Control Houston.